This lesson is on verifying identities. Verifying identities involves proving that both sides of an equation are equal using algebraic and trigonometric manipulations. For instance, show that sine squared x times the quantity 1 plus cotangent squared x equals 1. So in order to do this, you have to use some algebra and some of your fundamental identities together in order to prove that this is true. So the first thing that I would do in this particular problem is, since sine of x is sitting outside these parentheses, I'm going to multiply it into these parentheses. Now you may be wondering why I'm choosing to do this. Well, there's no real perfect choice as to what to do first in these. You just kind of have to get started in the problem in some respect in order to work through it. I'll give you some tips on this in the next slide, but for now, let's just work with this to see what we can do. So if I distribute sine squared x times 1 is just sine squared x. Sine squared x times cotangent squared x would be sine squared x times cotangent squared x. And that's supposed to equal 1, but I'm still not certain. So the next step, let's work with cotangent, because I can rewrite cotangent in terms of sine and cosine. So let's see what happens. So cotangent squared could be written as cosine divided by sine. So cosine squared x over sine squared x. Now, if you'll notice, in the second term on the left-hand side, I have a sine squared in the numerator and a sine squared in the denominator of a fraction, which can cancel away. And when those cancel, I now have sine squared x plus cosine squared x equals 1, which is a fundamental identity, so that proves that this is true. So I've now proven that that this is the case. Now, let me give you some tips and advice on how to work through problems like this. First off, always start with the most complicated side of the equation first. The issue here is when you have the complicated side with more terms, you're going to have more likely things that will cancel out. If you start with the simpler side, then probably you're going to end up having to multiply in or add in terms that don't exist already, which is a whole lot more difficult to make up things that don't exist that will work rather than finding things that will cancel. So start with the most complicated side first. Secondly, one thing you want to know is you're not going to be given an identity that doesn't work. So there's always going to be a way to get from the right-hand side of the equation to the left-hand or vice versa. It's just a matter of using the correct identities in algebra to get there, but it will always work. You can always work on both sides and try to meet in the middle. And this is especially helpful if both sides of the equation are like equally complex. So if you have things that you can cancel out on the left-hand side, things that'll cancel in the right-hand side, and you can meet it in the middle. That's a perfectly fine strategy as well. Another great strategy, if you get stuck at any point, just write everything in terms of sine and cosine. Use those fundamental identities, and that will often give you things, fractions that you can combine, things that might cancel. Writing everything in terms of sine and cosine usually is a very good strategy. If you have any fractions, combine those fractions by getting a common denominator. If you have a common factor, pull one out. Or if you're given a common factor, distribute it. That's usually a great thing to work with. Multiply binomial terms using FOIL, or if you have a quadratic that might factor, go ahead and factor it. Multiply by a conjugate. So if you'll recall, the conjugate of a binomial is like if you have 1 plus sine x. The conjugate of 1 plus sine x is 1 minus sine x. When you multiply those two things together, you get the use of the difference of squares. And in this case, 1 plus sine x times 1 minus sine x would be 1 minus sine x squared, which is the same thing as cosine squared. So multiplying by conjugates can sometimes help out in allowing you to use the Pythagorean identities. So let's work with some problems. Starting with tangent x sine x plus cosine x is equal to secant x. Now, to tell you again, these things, you're never going to get one that doesn't work. So just pick the most complex side of the equation and just get started in it and see what happens. So I'm going to begin with the left-hand side. So I have tangent x sine x plus cosine x. And I'm not really sure exactly where to begin, but I do know that I can write tangent in terms of sine and cosine. Let's just see what happens if we do that. So tangent of x is sine x over cosine x. And that's still multiplied by sine x plus my cosine x. So what I've done is I've just changed tangent into sine over cosine. I still have this sine x, and I still have this plus cosine x. So I haven't really changed much except for the tangent. But now I have the fraction sine x over cosine x times sine x. I could combine those into a single fraction by multiplying the numerators and multiplying the denominators. And notice I'm not really involving the right-hand side of the equation at this point. I'm starting with the left-hand side, which is this right here. I'm working toward that right-hand side. So in the end, when I get this equation to look like secant x, then I know that I'm finished. So I'll make like a complete statement here. All right, so now it's probably possible to combine these two fractions, the sine squared x over cosine, and effectively cosine x over 1. You can think of it that way. You could rewrite these as a having the same common denominator, add them together. So let's try that. Common denominator would be cosine x in this case. So I don't need to do anything to the first fraction. The second fraction, I need to get that denominator to look like cosine x. Well, I multiplied 1 by cosine x to get that there. So I need to multiply the numerator, which is cosine x, by cosine x to get cosine squared x in the numerator. Once you have fractions that have the common denominator, you can add their numerators together, put them over that common denominator, and then go from there. So in the numerator, sine squared x plus cosine squared x, that's a Pythagorean identity, which is equal to 1. Now I have 1 over cosine x, which is equal to secant of x. And that's now my right-hand side of the equation. So I've gone from the left-hand side, filled in the details all the way to the right-hand side. So I am finished. Couple of things to keep in mind. There always will be a way of getting there, and your instructor will look at your algebra in a lot of detail. So randomly picking things that look like might work, trying to fit it in, if they don't mathematically make sense, you won't get credit. So at least go as far as you can, and then if you get stuck, ask your instructor on how to proceed from there. Don't just make up your own mathematics as you're going through. Now, another thing that I discovered when I was taking trig is a way of verifying that you've done your algebra properly. So for instance, let me pull up the calculator real quick and show you what you can do. Now, because all of these functions are based off of identities, you have the exact same graphs for each of these functions. It's always going to be the exact same graphs. So for instance, let me show you what I mean. So if I put tangent x times sine x plus cosine x in for y1, and I put secant x, which is 1 over cosine x. We don't have a secant button, so this is how you have to do it. Let me make sure my mode is in radians, good, and then my window is appropriate for that. Should be fine. Alright, if I hit graph, it graphs y1 to start with, and it may look strange, you know, but when it finishes graphing that, it starts graphing the y2, which is the right-hand side of the equation. And it maps the exact same set of points because these are identities. The points of the graphs match at every single point. So if you want to verify that you've done your algebra properly, you can do this between steps. So for instance, if you're not sure that tangent x sine x plus cosine x is sine x over cosine x, so sine x over cosine x times sine x plus cosine x. If you're not sure of that step, for instance, graph one side as y1, the other side as y2. And if it graphs the same set of points for each of those, then you're assured that you did your algebra properly. So you can kind of check your steps as you go along. All right, as this maps, it's doing the second set at this point. You can kind of see the little progress indicator in the upper right-hand corner, meaning that it's doing something. It doesn't look like it is, just because it's mapping the same set of points. Now that it's done, you're fine. So if you had, for instance, chosen cosine over sine instead of sine over cosine, graph that. Here's the left-hand side of the equation. Give it a moment to graph that in. And here's the right-hand side. Now look, it's not mapping the exact same set of points. So that means I did something wrong in that algebra, you know, and I need to go back and check my steps. So you can kind of verify step to step that you've done your algebra properly just by making sure the graphs look exactly the same from one step to the next. Here's another problem. 1 plus cosine x over sine x plus sine x over 1 plus cosine x equals 2 cosecant x. All right, so obviously the left-hand side is the more complex side, so let's begin there. So I've got two fractions basically, but the denominators are not the same. So I'm going to do a little bit of work in getting a common denominator between those things. So in order to do that, I would need to multiply the first fraction by something and the second fraction by something else to get a common denominator. So the first fraction would need to be multiplied by 1 plus cosine x over itself. The second fraction would need to be multiplied by sine x over itself. Because then what I end up with is effectively 1 plus cosine x, quantity squared in the numerator, divided by sine x times the quantity 1 plus cosine x. And in the second fraction, I'm going to have sine squared x over 1 plus cosine x times sine x. Now, the denominators are the same. I have the multipliers written in the opposite way, but it's fine. They're equal to each other. Let's see where to go next. Now, this 1 plus cosine x quantity squared, this is a binomial that is squared that I could work with that. The reason I'm going to choose to do that is because if I multiply that out, I'm going to get a cosine squared term, and I already have a sine squared in the other numerator, so those are probably going to work into a Pythagorean identity. To square out a binomial, remember the formula. A plus b quantity squared is a squared plus 2ab plus b squared. The most common mistake students make here when squaring a binomial is just squaring the first and squaring the second. You're going to lead to wrong answers there every single time. So don't forget that middle term, the 2ab. So when I square this out, it's going to be 1 plus 2 times the first times the second, so 2 cosine x plus cosine squared x. So that's the first numerator squared out. Then it's going to be plus sine squared x, which is in the second numerator because I'm combining these two fractions together, and putting it over the common denominator of sine x times 1 plus cosine x. Okay, now, as I mentioned, I'm going to get these two terms that I can replace with a 1 because of the Pythagorean identity. So I'm going to do that. So since those will add up to a 1, I'm going to go ahead and combine it with this other 1 right here. And this is going to be 2 plus 2 cosine x all over sine x times 1 plus cosine x. And the numerator, there's a common factor of 2 that I can pull out. So 2 times the quantity 1 plus cosine x over sine x times the quantity 1 plus cosine x. Now notice there's a factor that's shared in the numerator and denominator. The whole factor, 1 plus cosine x, is going to cancel out in each one and leave me with 2 over sine x, which I could think of as 2 times 1 over sine x, or 2 cosecant x. So I'm now at the right-hand side of the equation, and I've proven my identity at that point. So that one was a bit trickier. It involved a lot more algebra. But the thing is, all of that was really still guided by those principles that I gave you. You know, I knew what to do because I had fractions. Combine your fractions. I had a binomial that was squared. Foil that thing out. You know, I found a common factor of 2. Pull that common factor out. So there's generally some clues as to what to do, no matter how complex the problem is. Factor the following trigonometric expression. So 3 sine squared x minus 14 sine x equals minus 5. So the factoring here, this is something that you might have to do at some point in the class, not necessarily right away, but it's a good thing to be thinking of ahead of time. This is essentially a quadratic but it's not exactly a quadratic because we have the sine squared and the sine x written there. You can factor with functions other than just x. That's perfectly fine. So like for instance, if I start factoring using the process that we sort of developed back in early algebra, the first thing that you need is two things that would multiply to 3 sine squared x. So 3 sine x and sine x would work for that. And then you need two things that would multiply to -5. So 5 and 1 would work. And since I need to get the middle term to 14, I'm going to put the 5 so that it multiplies against the 3. And I think that will work. As long as the 5 is negative and the 1 is positive. Now if you go back and check your work, this works out just fine, because 3 times sine x is 3 sine x squared. 3 sine x times -5 is -5 sine x, or -15 sine x. 1 times sine x is plus sine x. And 1 times -5 is -5. So this is 3 sine squared x minus 14 sine x minus 5. So it works out just fine. And you can work the problems in that way. An alternate method, if you prefer, is to use U-Substitution. So for instance, if I let u equal sine x, and then rewrite this as using that substitution, 3u squared minus 14u minus 5, then this thing right here factors in the way that we normally would have. So 3u and u, 1 and 5. And if this is a minus and that's a plus, that's good. But then we just have to substitute back in for the original variable. So we would still get 3 sine x plus 1 times sine x minus 5. Either way, you get the same result. Whatever you prefer there is perfectly fine. But do know that at some point you will need to be able to factor quadratics involving trig functions. Now, lastly, I want to pull up your homework and give you an idea of what's going to happen in solving some of these problems. Some of them you're going to be required to show your work, and in order to show your work, I'll show you what you need to do and let you know that you need to email me when you're done doing those problems so that I know to go in and check them for you and give you credit for them. The reason that I'm doing some problems like this is because when you go to take your paper exams, you're never going to have multiple choice style proving equations, so proving identities. And so you need to have practice with proving identities in the way that a paper and pencil test would be done. And the only way we can do that is to show your work problems. So let's pull that up and I'll show you what I'm referring to. So here's a problem similar to what you might experience in your homework. You're asked to show your work in order to prove that you can do this identity. So you have the left-hand side, the right-hand side. You got to fill in the details in the middle. So in order to do that, let's just start with the left-hand side since it looks like the more complex side. So cotangent x times tangent x plus secant x. My expectation is that you would work this out on paper first and then go to input your answers later. That way it's easier that way because, you know, simpler to erase than to type over and whatnot. What I'm going to try is first distributing the cotangent x. So I would have cotangent x times tangent x plus cotangent x times secant x. cotangent times tangent, if I rewrite those in terms of sine and cosine, I would have cosine x over sine x times sine x over cosine x. What's nice is that's all going to cancel out to just 1 basically. Over here I've got cotangent, which is again cosine x over sine x, times secant x, which is 1 over cosine x. So in the first set of fractions, the numerators, sine and cosine, all cancel away. In the second fraction, I have a cosine in the numerator and denominator that cancel. So this becomes 1 plus, and then 1 over sine is going to be cosecant x. And now I'm at the right-hand side of that equation, so therefore I've proven this identity. So, showing work. Let's see how that happens. In order to show your work, you have 2 options here. Click the Show Work button, and you can click Insert Image, and that will allow you to upload a picture that you've taken with your phone or something. And that way you can just, take a picture of your work. Alternatively, and actually my preferred method, is to use this equation editor here. It's pretty simple to use. You click on it, and then just click anywhere in the box, and it'll start a little equation box. Now you can just start typing away. So for instance, cotangent x, and it recognizes cotangent as a function, times the quantity tangent x plus secant x. That's the beginning of the problem. And then I distributed, so I got cotangent x times tangent x plus cotangent x times secant x. And then I changed these into fractions. So I have cosine x, and if you just hit divide, you don't have this little toolbar where it gives you fractions and square roots and things, but if you just hit divide, it'll make a fraction. So cosine x over sine x. And then if you hit shift and 8, which is the star, it'll just give you a little multiply symbol. And then sine x over cosine x, and plus cosine x divided by sine x times 1 over cosine x. And if you get too far and you don't have not enough space to finish out the problem, just do another line down here. That's fine. And then things canceled away, and it equaled 1 plus cosecant x. And then that's enough for me to see that you've done your work properly. And that's perfectly acceptable. You just hit save at that point and email me and let me know that you've got your show your work ready. Then I'll go in and take a look at it, give you credit, or if you need to do some more work on it, I'll give you some pointers on where to go. But that's all there is to it.